Let's take a look at this example. I would start solving this problem from drawing the voltage sources. Okay, so this is my VEE. Okay, so this is my negative terminal of my VEE. This is positive. And I have also my VCC. Okay, so this is my positive terminal. This one is negative. This is my ground, and of course the positive terminal of my VCC goes somewhere to the circuit, and this is my VEE. Next, in order to find the value of resistor R2 and resistor R1, I'm supposed to realize that the base current, okay, is very small comparing with IC and IE. That's why I'm going to assume that IC, okay, is approximately equal to IE. Okay, and this is going to be equal 3 milliamps. Okay. Next, we're supposed to find voltage at the base of the transistor. Now we're supposed to keep in mind that we are dealing with the conventional current flow, so current is going to flow from the positive terminal to the ground. From the ground will go to the resistor R1. From R1 it will go to this node, right? And current is going to split into the current which will go through the Zener diode and current which will go through the base. Okay, so as we said before, the current which will go to the base is going to be very small, so most of the current will go through the diode. So you can say that VB is equal VZ plus VEE. Okay, because current is going to go in this way. This is going to go like this, and it's going to enter the resistor from this side. That's why I'm going to label this terminal by positive sign, and it's going to leave the resistor at this terminal, so it's going to be negative, and it's going to enter the Zener diode. So I'm going to have positive over here and negative over here. So if you want to find the voltage is going to be nothing else, just voltage at the base is positive voltage of the Zener diode plus my VEE. So VZ is given, this is equal 5.1 volts plus VEE. VEE is equal negative 10 volts. Okay, so this is equal 5.1 volts positive times negative will give me negative, so minus 10 volts is equal negative 4.9 volts. Okay, so this is the voltage at the base, okay, of my transistor Q1. Please notice that the voltage at the base is the voltage between the base and ground. This is also voltage across resistor R1. That's why we say that VB is equal VR1, and this is equal negative 4.9 volts. Next, in order to find the value of resistance R2, I'm supposed to find voltage across resistor R2. So in order to do so, I'm supposed to find VE first. Voltage at the emitter of the transistor Q1. VE is equal VB minus VBE, where VB we found is equal negative 4.9 volts minus VBE, which is given 0.67 volts. Okay, so this is equal negative 4.9 minus 0.67 is equal negative 5.57 volts. Okay, so this is the voltage at the emitter. Next, you're supposed to realize that VR2, this is also called VRE, because this is the resistance RE. Okay, in some books you are going to find this resistor labeled RE, is equal to the difference of voltages VE minus VE. Okay, where VE we found is equal negative 5.57 volts minus VE negative 10 volts. So VR2 is equal negative 5.57. Negative times negative is positive, so plus 10 is equal 4.43 volts. So this is 4.43 volts. This is the voltage across resistor R2. So please notice that we have already the voltage across resistor R2. We have current which will go through resistor R2, because we said that the current which will go through the resistor R2 is going to be equal to 3 milliamps. I can find the resistance. So R2 is equal VR2 over IR2. So VR2 is equal 4.43 volts divided by IR2, which is equal 3 milliamps. Okay, this is equal, divided by 3 exponent 3 negative, 1.47 kilo ohms. Okay, so my resistance R2 has value of 1.47 kilo ohms. Okay, next we're supposed to find the value of resistance R1. In order to do so, we're supposed to find the current which will go through this resistor. The formula for current, so this is my IR1, is equal approximately 1.2 IZT, okay, where IZT is the minimum current required to cause the Zener diode to conduct in reverse region, okay, and this parameter is given, okay. This is equal 20 milliamps. That's why I'm going to write that my IR1 is equal 1.2 times 20 milliamps. Okay, so this is equal 24 milliamps. Okay, so this is the current which will go through resistor R1. Next, I supposed to simply write the formula for the resistance. R1 is equal VR1 over IR1, where VR1 we said is equal negative 4.9 volts, so negative 4.9 volts over IR1. Okay, IR1 is equal 24 milliamps. Okay, and because the current is going to go from the ground up, okay, so I'm going to write over here negative sign, and please keep in mind we're supposed to keep this negative sign because resistance cannot be negative, so negative and negative will cancel out, and I'm going to have 4.9 volts divided by 24 exponent 3 negative. This is equal 204.16 ohms. 204.16 ohms. Okay, so if you are going to look for the value of resistor R1, this is going to be equal to 200 ohms, because you are not going to find the resistor with the nominal value 2 or 4.16 ohms. Okay, so this is going to be your R1. If you will need to find the resistor R2, so you're supposed to find the resistor 1.5 kilo ohms. Okay, so because you are not going to find 1.47 kilo ohms. So we found the values of resistor R1 and R2, so we can say that the problem is solved.